Oh, wouldn't you know it, I was just drilling through here, drilling all the clearance holes out, ready to do the tapping, and I managed to, so in that one there, break the end of the drill off. Welcome back to the workshop. So in this video series, I'm trying to work out the best way to fit some kind of mist coolant system to the CNC machine, and that hopefully will give me a little bit more success when I'm cutting materials, especially gummy materials like aluminium. So to help with this project, I've gathered quite a few things now. So I've got an extra valve down there, a regulator, got another relay, various fittings, push fit tubing, all the sort of things that I think I might need. I've made some little brackets to hold the regulators on, and over here, this has just arrived, a nice big bit of aluminium. Before we get into what we're going to do with this, we need to head back up to the fixture, and I wanted to try one more thing. So this is the fixture you saw me use last time. So we've still got our tank up here with the water in it, a couple of regulators. The new thing I've just added, just to make it a little bit easier to test, is this on-off switch. Now I have tested that, just plugged into the regulator, nothing on the other end, and it's pretty good. It does switch it off completely and there's no leaks, so pretty impressed with that. But that'll allow me to control it a little bit better. Yeah, so in the last video you probably saw me try to compare with and without pressure, but it wasn't a great visual comparison because the nozzle was down in the cup for one of those tests, so it made the mist a little bit more apparent. So I've got it as far away as possible, and we'll just try and repeat this without moving the camera, without moving anything, get it set up and just try directly back to back. What's the effect of pressure on here or not? Because personally I'm starting to wonder whether it's worth the hassle. I think once you've got maybe a fine little drizzle of coolant, MQL, going through here, yeah, maybe you don't need that and just keep it simple. But let's have a look, you know, in the interest of finishing off the scientific tests, and let's see what conclusions at least I can draw from that. All right, let's get this set up and let's get going. Okay, so I haven't changed anything since last time, so we'll see if these regulators are set okay. But the first thing is we need power on here. Yeah, that's okay, and we need to open, I don't know, I guess we could do this first. Is that way to open it? I think so. Let's switch this on. Should open the relay and solenoid. So in terms of airflow, we have got 30 psi to bar, and in terms of pressure on the top of the tank, maybe 5 psi, half a bar, pretty hard to tell, but we've got a little bit of pressure, maybe, and we'll just open that up a little bit. There we are, maybe 10 psi, 1 bar head of pressure on the tank. Right, let's set that up, get it so it's misting, and then we'll take that away and see if it gets worse. Okay, so just to help with the contrast, I've put something that's about as dark as I've got in the workshop, unfortunately. So right now, we've got a little bit of coolant on there. Hopefully you can see that. So, you know, it's set reasonably well. So, you know, to be honest, I'll be happy running it like that. So let's see if we can get this to really mist. And once it's about as, you know, really going for it, then we'll take the pressure off and see what happens. So this is with that pressure applied on the tank. So we're adding more coolant, and you can start to see now. I guess, to be honest, it'll just get worse and worse. Let's go with that, and now we'll take pressure off the tank and open it to atmosphere. Okay, so this is the feed pipe that we put pressure on. I wasn't watching. Has that got worse? I think so. Put the pipe back on. some pressure on. There we go, here comes the pressure. Of course, that's increasing the flow as well. You know what? Turn it off. Well, to be honest, I'm not really sure what to make of that, because of course once I put pressure on the tank it would naturally try and push more flow out, so to make it fair I'd have to dial the valve back, and then, you know, what are you changing? Too many parameters. So I think from what I can see, if you leave this open to atmosphere, you can just run airflow as a venturi, keep this wound in so you've got the barest amount of fluid coming out. That seems to work okay. It wasn't misting. Now maybe when you do this with WD-40, this is just water, maybe it's a bit different, I don't know. So just in case it is a little bit different, in my design I am going to keep the ability to apply pressure to the top of the tank, but maybe in the first instance, yeah, I'll have the regulator there, but maybe I won't put the plumbing in for that, and we'll see how we get on. If it turns out I need it, I can easily just put the pipe in. So anyway, I don't know really actually how scientific this is. You probably need to monitor a few other things like the flow rate, make sure that was a fair test. I'm just coming to the conclusion that maybe you can just get away with one of these, air flowing past it, and just put the other pipe into the tank and it sucks it out and away you go. That's kind of where I'm at anyway. While we're here, we'll answer some of the other questions that were asked. No, I don't think this is an adjustable nozzle. As far as I can tell, that's just screwed into there. There's nothing that appears to twist. I think that's just one piece just turned. So you get what you get out the end there. And then the other question was about that. Well, what you really should have in this pipe is either a check valve, one-way valve, something like that. There is a check valve in there, so it doesn't allow the flow to come back down. The other thing is that it makes it very difficult for this to drip and self-siphon, because that would create a vacuum. As soon as a little bit of fluid starts to come out, because of that check valve and the diameter of the pipe, you know, the needle, it just can't really get that fluid out. So I think the back siphoning is a bit of a non-issue. It was recommended to go ahead and get a one-way check valve anyway, because maybe these are not very good, you know, a proper one-way valve. So I'll have a look into those. But I think, as far as the testing I've done and my kind of hands-on visual experience, I've got a pretty rough idea of what I'm going to do, and hopefully that's going to work. So basically what I need to do now is get all the pipework and valves onto there, mount that to the machine, figure out where I'm going to mount the filter container, and there we go. So let's get to it. Okay, so we've spot drilled all the holes out. I don't like drilling on this machine because it's a high-speed spindle and it bogs down quite easily if you're drilling. You can get it to work, but it's a bit 50-50 I've found. So I like to spot them out and then I'll just finish them off with the cordless drill. The other thing was the stock was cut by the supplier to the right length, but the width was a standard width, so I just had to trim that off. As you can see, I've gone almost all the way through, so when we take this off we'll just clean that up, not a problem. Some of these holes are clearance to 6mm, some are drilled and tapped to M3 and some are drilled and tapped to M5. So I'll get these marked out a little bit more now that it's convenient here, and then we'll take it over to the vise and then make sure I drill out the right holes to the right size and either clearance or tapping. So let's get going with the drill. And in case you're wondering why I didn't do it on here, yeah, that doesn't really fit in the jaws, so I could have clamped it to the table and I've had to put a spoil board on, get it all set up. This time the CNC option I think was the better one. Oh, wouldn't you know it, I was just drilling through here, drilling all the clearance holes out, ready to do the tapping, and I managed to, so in that one there, break the end of the drill off. So it's snapped off and it's in that hole. Good news is it's in quite a long way and this is only 8mm thick, so what I think I can do, I've got the drawing here, so I know where the hole is relative to these edges, so I'll take it out of here, turn it round on the reverse side, set it up on my plate, mark the hole on the back and drill it from the back until I feel like I'm hitting the broken end of the drill, stop there, and hopefully I'll be able to kind of knock it out and clear up the hole. Good news is an M5, so it's quite a lot of material to remove, and then we can progress with this job. So let me get on with that and then we'll bring you back. Okay, so we'll gently go in with this 3mm drill, hopefully it won't break, and hopefully we can feel when it's hit the drill bit. I think it's there. Might be pushing it out. Yep, that'll be it then. Okay, so we've gone through. I think it just pushed the end of that drill out. Oh, we got lucky. Okay, so I'll drill and tap all these and then I'll bring you back. Okay, let me show you where I decided to mount it. So when I run the CNC machine, I'm normally just standing over here near the keyboard, got the mouse, got the controls up there, so I don't need to move. I've got the emergency stop down here. So I wanted to mount this panel, which is going to have all the air control, mist control system on it. Thought down here would work quite well. So I think I'm going to mount it somewhere there, so flush with the edge of the cable tray support here. So there'll be 3 fixings, 1, 2, 3. Everything else is control the regulator. You'll have solenoids on here. Also be some push buttons for the air blast, an on-off valve, all that kind of stuff, and then all the outlet pipes will go up into the tray itself and then into the drag chains and up to the spindle. Okay, so you can see the compressor down there. I'll run a line up to there for the air, and then that will go into that unit. So the next thing to do is mark out those holes and drill and tap them into the frame. Then we'll take the plate over to the workbench and start mounting up the components. Okay, now we know that fits, we'll take it off, we'll put this on the workbench and we'll start putting all the components on. So I've got to a point in the project now where I've made the board, I've drilled and tapped all these holes, made a couple of brackets to hold the regulator on, and then we've also got these spacers that I can space the pipes out, then they enter the other pieces at the right height. Some other bits I've made up, so I've made this kind of spacer adapter block that holds the solenoid on and again gets it to the same height, so they're all, they're all in line with each other. And I think we're about ready to put this thing together and see what we've got. So let's get started on that. So it's the first time I've used this kind of push fit system with all these little elbows and T-pieces and the regulators and so on. Yeah, it seemed to go together pretty well. You can cut the tubing with side cutters to the right length. You just seem to, well, you need to make sure it goes past the gripper and past the seal, but not too long so that you can't actually do the bolt up into the fixing into the main plate. But yeah, that went okay. Yeah, so you can cut it with that. I'm sure there's a special pipe cutter, but the side cutters worked okay, for me at least. So we're getting the little elbow ready, lining it up with the screw hole. Yeah, so it's pretty easy, just push it together. Also there's a little release clamp around those. You see the blue ring, so if you need to get it out again, it's nice and easy. The main issue is basically just make sure the pipe was long enough, but not too long, so you couldn't line up the bolt holes. So here's the solenoid going in. It's for the main mist system. And then there's those little standoffs that turned on the lathe. That just gets it all to the same height, really. I'm not quite sure what you're supposed to do, really. Because if those little fixings end up being flat onto the base, you're going to end up with an S shape or a kink in your pipe, which doesn't seem right. So not sure what the intent is. So I made the standoffs and that worked pretty well. Pretty pleased with that. Now those are little M3 screws with the button head on. I had to order those specially, so super length, nice and long, so they go all the way through and into that plate. Then the last bit at the top there, that's the solenoid for the blast. Just give the intermittent blast. Don't know if I'm going to need that, but we'll see how we get on with it. It's obviously going to be restricted, the flow through the little solenoid, but let's see how it works. Okay, so that's the basic system laid out here. So there'll be a little control panel here, so I can turn it on and off, but the buttons haven't arrived yet. So I think what we can do is pressure test this at least. So the air compressor will come in here. We've got that solenoid there that will put the blast out. So that's if you just want just an intermittent blast just to clear the chips. And then the air also goes through here. We've got the solenoid here. So when you switch that on, it runs the air to these two regulators. I've decided, on balance, I am going to put a little bit of pressure on the tank, or at least give me that option. And then I'll have my main air pressure that will go to the Venturi over here. So these will go out to this, and this will be mounted on the machine. So I think what we'll do is try and block these off and just pressure test it and make sure we haven't got any leaks. Right, now I know it's not easy to see, but essentially what I've done, I've just ran this line up to here and then shut this off, and then ran this line through there, through the 4mm into there and shut that off. So basically I'm blocking them off using the Venturi here. So if we turn the system on, put some pressure in, you can hear something, it's very slight. So this one's okay, but that's losing pressure somewhere. I think it's on the gauge. Okay, I spent a little bit of time playing around and trying to seal up all the joints. So I ended up, I think I had a spare one of these, so I've replaced that because the thread is actually very thin on those. Redid the PTFE tape on that one a couple of times. I think I redid that joint, and that one. I think that one was okay, and it pretty much is holding. There is a real faint leak that's extremely slow. Now obviously I've got the system blocked off here, so it's sealed. So it's, you know, real worst case, when it's actually running, there will be some air going through. So I'm sort of tempted to leave it. I can't really quite see where it's coming from, and in practice it probably doesn't matter. It's extremely small, but so small I can't feel, but I can just about hear something. So let's just open the valve. So I'll get those both set to 90. Now I was trying to get them aligned, but I'm worried if I do this one anymore, I might break the thread off there, and if I undo this one I might lose the seal. Well, I've just taken these apart again, put PTFE on both of them, put plenty on this time, or even more than last time, and then align them so the zeros are the same, but there's still a very faint leak. I can't quite tell, maybe from this gauge here. Maybe just the quality of the threads, I don't know, or you'd have to put a lot of PTFE, or maybe the hard setting compound for thread locking, I don't know. Anyway, it's extremely slight, so I think we'll just run with it like that. Okay, so I've got most of it laid out now. So I've got all the solenoids are in here, and the regulators. These are for the cable run that will power the 24 volts to the main system. That will come from the CNC controller. Then I'll just turn these on the lathe. They haven't been drilled and tapped at the end yet, because I'm not quite sure exactly how long they're going to be, but they're just screwed into there. And basically what's going to go here is a control panel, and this will house the two switches, one for the blast that will control this relay, and that will be momentary, so you can just, as long as you hold it down, it will blast the air. The other one needs to be a latching switch, and that controls this relay, and that will run the mist system. I did think about whether to have a rotary switch and then have like automatic and manual mode, so you can manually set it, or in auto, if you got a signal from the CNC program in the G code, that could trigger it via a relay on the board. But I think I've decided, at least for now, to go for a latching switch and just use it manually. I can easily swap it out, and the cable will have enough runs in it so I can have that feed in there as well. I think 3 or 4 core cable I've got ready to go in there. So the plate that goes on here looks like that. So it's just a sheet. I've got it set up on the CNC machine. I'm going to cut it out, and then we'll bend it, and then it's basically just got a couple of holes in it. So these two, actually, although they're 22, I've recoded it for 16. So the switches I tend to use are these ones. These are 22. The popular ones are all momentary. I did manage to find some latching ones, but I'd have to order those from China. The other thing is they're quite bulky because they're designed to have, you know, monitoring functions and all sorts of things. I basically just want a simple switch, so they end up being quite big in there. So I've got some sort of equivalent 16mm ones on order. They haven't arrived yet, but that's okay. We can still make the main housing. And then this hole down the bottom here, this is for, I've got it over here. This will be where effectively the on-off valve will come through there, and then that will be held on by, on the underside, by this little bracket. So that should go, yeah, you can see those holes line up there. So that will hold that onto there, and then that will hold that onto the plate. So effectively that'll sit through there, and you'll have the on-off switch and 2 buttons. Right, so I've got the blank set up on the CNC machine. Let's go and cut it out. Okay, so I've got my sheet clamped down onto the spoil board here. I've decided to use a 4mm end mill. This is really gummy stuff. This is the 1050 grade, so it's easy to bend. But unfortunately, yeah, it is then very gummy. Ironically, this would be the perfect candidate to have a mist system. Now, I did think about rigging it up temporarily and trying to run 24 volts to it, and, you know, getting something working at least. But I think what I'll do just for this last piece here is just use the hand spray and the air gun here, and just take it nice and easy, and hopefully it won't gum up and we'll be okay. And then we'll have a fully working mister. Okay, so there's a few holes to cut. I think I drilled in a few places just to take out the corners, and then we'll do a profile and a finish cut, and then we'll bend it, and that should be it. Well, that 4mm cutter, I know it was pretty blunt, but actually I did really well on here, so maybe that's the way to go for this thin stuff. So the engraving, that's 0.5mm thick. I did 3 lots of G-code. This is the 0.5mm depth. I did one at 1mm, and then I think the other one was 1.5, just to see what looked the best. That's actually looking reasonably deep, and I was hoping to get a little bit of paint in there and then wipe it off, just so we get the letters sort of stand out a bit more. But yeah, I think actually we'll go with that depth. That looks okay. Right, so we'll get this out of here, clean it up, and then I'll see you back at the workbench. Okay, and after a clean up and a bit of deburr, there it is. So pretty pleased how those letters came out. So that was only 0.5mm deep. It looks okay. So I think we'll paint those in, but leave that right to the end. So as you can see, I've marked up, sort of scribed it where I'm going to bend it, which is, you can see I'd already pre-drilled those holes to give me a bit of a guide. And basically you're just going to fold these two sides down 90 degrees, and then this will be the main plate, and it will just sort of cover up most of the wiring and switches. It's not supposed to be a complete box, just to give it a little bit of cosmetic touch really. And then these are the main fixings that will go into those standoffs you saw a little bit earlier. Right, let's get it in the folder, and let's fold these over. Actually, I just realised I'm going to fold these down, so I need to mark it on the back. Back in a minute. Right, I've marked it on the back this time. We'll try that again. Okay, zero that. Yeah, close enough. Right, do the other side. Okay, we'll go with that. Okay, that's the finished cover. Okay, now obviously I haven't drilled and tapped the holes in the end here because I don't know quite how deep this switch is going to go and the electrics which are just behind it, so I've left those blank for now, and maybe a little bit long, but hopefully you get the idea. I think the holes are central. Got clearance down there, clearance to that screw holding that in. There's an access screw down here, we've got clearance too. So yeah, it looks good. And we can actually put one more thing in then, which is, so we've got the on-off valve that goes in there, and I've got a little intermediate bracket. I think it went that way around maybe. Oh yeah. Alright, so let's get that screwed in at least, make sure that's going to fit. Problem. Right, so I'll just put the switch valve bit in there, the air valve. So the idea is, yeah, that's your on off. And then there were two holes there. They would go into a bracket. That was on there. That was all fine. And then this piece would be screwed to that, and that would hold it in place basically like that. Couple of problems. First is, so this is the valve with the 6mm inlets, and that's basically just arrived the other day. I hadn't tried it out, and I'd drawn the CAD for the parts against this one with an 8mm hole, assumed it was the same. It's not really. As you can see, it's got a different finish on it, so I've had to open that hole out a little bit, and then the hole spacing on the mounting block is not the same. So I don't really want to use this because it's got 8mm inlets, which means I've got to put 6 to 8 adapters. So that was the idea, I bought that one, but yeah, it's not the same. So somehow I've got to make it a bracket that holds that. I mean, it's pretty firm as it is, but I just think over time when you do that a lot, it might keep moving. And then got these two holes that obviously aren't used for anything. So I'll go and have a think and work out how I'm going to do that. Okay, cut to some time later, and basically I started again and made a new bracket there. It was a little bit tight, had to cut some bits away, but we got it in. So we got some little tapped M3s there to hold that onto the bracket, and then I can use the existing holes there and we can carry on with the build. So that's actually ended up quite a nice fit on that black collar there, so it's quite a nice push location. Okay, and we'll just put our two M5s in there, and that should be that. Okay, so I think that will be off, and that's on. Weirdly, it doesn't quite go 90 degrees, but okay, there we go. Looking good. Okay, now the two little switches still haven't arrived, so hopefully any day now. And while we wait for those to come in, I might as well get all the wiring in place so that they're ready to go when they do arrive. So I've just tidied all the pneumatic stuff out of the way, ready to do some electrics. Okay, not exactly sure how I'm going to do this, so I've just got a little bit of everything out. So we've got some connectors, some terminals there, some heat shrink, various crimp and ferrule connectors, and then a little bit of multi-core cable. So let's go and have a look and see how we're going to do this thing. So the main mist unit is going to go down here, so I've got to run a cable from here all the way up to the control unit up there. So I think I need to run two cables, one's from the 24 volt permanent, which will be the brown ones there, and then the 0 volts, which will be the blue, and run that down. Then I'll have the third one spare, so if in the future I want the mist to come on using the G code, I'll be able to just hook that up to a relay, and then it will short one of those out, and that will operate the mist system. So I'll at least have that capability in, but I won't wire that in just yet. Okay, so we're done at this end. I decided rather than take the power from up there, I already had these inlets and outlets here for 24 volts, so I thought I might as well make use of those. And then that earth wire, or the yellow and green you saw me stuff up there, that's for the future. So if I decide I want the mist to operate from a relay, I've got a little cable there, and then that can make connection to earth and switch the mist system on using the CNC G code. But for now, we'll just got the 24 volts and the 0. Right, let's do the other end. Well, I think that's about all we can do on the wiring until the little buttons arrive, which are taking their time, but ordered them from a seller in the UK thinking that'd be quicker. Waited 1-2 weeks. Yeah, there was second class post, but still waited 2 weeks, and then sent a message on eBay, said they hadn't arrived yet. I waited another couple of days and then said I think they've been lost. So they sent me some more, but obviously that's been about 2 days now, so I was hoping they might arrive today, but maybe tomorrow. Anyway, let's get on with fitting these, and then we can plumb in, at least do the air lines, and then when they arrive we'll just finish this bit off on the machine itself. Okay, so I've got our main pressure pipe fitted. All we need to do is make this connection to the Venturi, and then this is the mist pickup pipe from the tank. It goes in there. Right, we'll just clip this up out of the way, and that's the main Venturi bit done. Okay, I'm pretty pleased with the pipe run around there for those two lines, so we just need to plumb them in down there into the regulators. I was a bit worried passing these pipes through this metal cable tray here, so I've just used these. These are what you put on electrical boxes just to protect the cable as it goes in and out. And I just drilled a 20mm hole, and then this little grommet fits inside there, so hopefully that'll work okay. Right, let's connect these pipes up. Pretty pleased with that. Yeah, I think that's going to work. Okay, as you can see, I decided in the end to put the reservoir on the machine on the y-axis. I'm not too worried about the weight, and as somebody commented, yeah, if I get too much sloshing around and it affects the steppers in any way, I can put some foam in there just to try and dampen that down a bit. So I've got the pipe runs in now, the main airflow and the Venturi suction pipe, and they go all the way back down here to those two regulators there. So the only one we've got left to do is this one here, which is the blast line. So let's do that now. Okay, well, I've just hooked up the kind of blast line temporarily. I probably need to make something that goes around both those just to hold that in place, but yeah, we'll see how we get on with that. Just try it out really. And then I've just round that back there. It's a bit close to that corner there, so just put some protective sleeving on it. And then it runs through the cable chain, and then finally down here. And because it was quite close to it, I just decided we'll just put this 90-degree connector on. Okay, so I've got everything plumbed in, all the lines going through, the reservoir's in place. We haven't got anything in it at the moment, but that's okay. So we just need those buttons for the control panel, and then we can finish that off, and then we can try it out. And by the magic of YouTube, the switches have finally arrived. So here they are. So you can see all the connectors at the back. They're these slimline little spade terminals. Or I guess you could solder onto those as well directly. And then I've got two types here. So the blast one is just momentary, and then the mist one, latching. So obviously you want to keep that running all the time and then switch it off like that. Now it's got a little bit of protective film on at the moment, so when I take that off it should be quite nice shiny blue, but we'll leave it for now. So there we go. So in terms of the terminals at the back, you've got, probably quite hard to see there, maybe on that one. Yep. Oh, I'll just read them out. Anyway, you got, I can't see them either. There we are. Common, a normally open and normally closed across there, and then these two are the plus and minus for the light itself. Now I did wonder if the light would only come on once you activate the switch, but what happens is as soon as you put power across there, it just comes on irrespective, so it's just a general illumination. I did actually wire it so that one of them could get power from the terminal once you press the switch. So basically once you switched it, it turned the light on and it ran the solenoid as well. But you know it's going to run because you can hear it running. So in the end I decided it was too complicated on the wiring to do that, so we're just going to use two of the terminals. So there's the common and the normally open, and that'll be out. So I've got the spade terminals made up on the other end, so let's take it over there and hook it up. Oh, before I do that, sorry, let's just bring that back again. Yeah, these, I didn't have any of these. My other spade ones are too big. But I did find that the ones that come in this set, where you can make your own connectors up, obviously just basic connectors, not waterproof or anything, they fit on there really well. You see they'll go on there. The only thing I did was on the base there, they've got that kind of non-return tang, which I don't really need, and there's a risk of it shorting, so I just squashed those down. and then I could crimp them using my standard crimp set there. It's the 1mm one. I know that because I always make a note to myself which one I need to use. You can see there, and there's the type as well if I need to reorder. Yeah, and then that just goes in. In there, and then it crimps the outer part of the cable and then the inner part of the cable. Now we definitely will go over to there and let's wire it in. That's normally open. Okay, so just put the compressor on. So we've got live air coming in here. That's off at the moment, so we'll turn that on. Okay, I heard a bit of air go through, so that's okay. Well, the blast one should operate this. Okay. Coming out of this one at the moment. So as I say, I don't know what I'm going to do here. I might get another one of these pipes, or I might route this high pressure so it joins this and comes out that nozzle at the same time. You're going to have a manifold at the top, don't know. Okay, and let's try the mist. So that's this one. There's our main pressure, and then there's our tank pressure. Now there's a little bit of residual water in the line, and I think that's what's coming out. And can we do blast at the same time? Oh yeah. Now I need to adjust these, but I think that is a success. Okay, we'll let that dry and then give it a light sanding, and that should just take it back to the pure letters. You can see it's spilled out of the S a little bit there, but that's okay. We'll sand that down and hopefully that'll look okay. Right, back in a bit. Yeah, I'm pretty pleased how that turned out. I think that'll work well. So I can easily access these regulators here to control the pressure for the mist through the venturi, and then the pressure on the tank if I need it. I've got the mist on off and then intermittent blast there, and then that's my isolator for the air. So yeah, I think that's going to work really well. Yeah, so I've still got to put the WD-40 in there, and then I'm still thinking about what to do with the high pressure blast line that's down there. Maybe somehow duct it into the venturi system here, or have a manifold so that goes in, and then basically the blast of air will come out the same nozzle as the mist. That could work quite well, but I'll have a think about that and see what I come up with. So I'd hoped in this video I'd get enough done and then be able to do some test cuts with and without the mist on it and just see how much better it was, but I think I've kind of timed out there, so we'll call the video there, and maybe we'll look at some test cuts in the next one. So as always, thank you for watching, hope you've enjoyed it, and see you next time.